Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Thank you! Ngayon pag-uusapan natin about power, flow, and efficiency of an alternator. So ito yung part 2 ng ating discussion last video about efficiency of alternator. So, we discussed to our last video the different losses na na-experience ng isang alternator o synchronous generator. From input power, mababawasan siya ng mga copper losses. We have also the friction and windage losses. We have core losses and stray losses. Sa copper losses, we have field winding losses and armature winding losses. While yung core losses natin, yung ating mga hysteresis losses and the eddy current losses. So, because any mechanical process experiences some losses, no AC generators can be 100% efficient. So, a high percentage of efficiency in an alternator signifies better performance. Meaning, so habang lumalapit sa 100% yung ating value ng efficiency, mas maganda ang performance niya. So, the efficiency of an AC generator is the ratio of the useful output power to the total input power. So, mathematically, pwede natin siyang i-express as the efficiency is equals to output power all over the input power multiplied by 100%. So, yung ating efficiency, the percentage efficiency, is represented by the lowercase Greek letter eta. So that is also equal to P sub O, the output power, all over P sub I, or the input power, multiplied by 100%. So for the output power, it's just simply square root of 3 multiplied by the line voltage and the line current multiplied by the cosine theta or multiplied by the power factor. So alam natin yung input power natin is equals to the output power plus the summation ng lahat ng power losses. So ibig sabihin, yung ating original equation, pwede nating express uli sa output power all over the output power plus the summation of the power losses multiplied by 100%. So, on the other hand, pwede rin natin siyang express using this formula, the input power minus the summation of the power losses all over the input power multiplied by 100%. For the copper losses, is simply that is equals to 3 multiplied by the square of the current multiplied by the armature resistance. While for the field winding losses, that is equals to P sub F is equals to the field voltage multiplied by the field current. Or simply I squared multiplied by RF, or simply B squared over RF. So let's have practice problem. An alternator is rated 25 kVA, has a total losses of 2 kilowatts when it delivers rated kVA at 0.76 lagging. So calculate its efficiency. So yung mga given natin, the parent power is equals to 25 kilovolt ampere. The summation of power losses is equals to 2 kilowatts. And the power factor is 0.76 lagging. So we are asked to solve for the efficiency. So let us solve the output power first. That is equals to apparent power multiplied by the power factor. And that will give us 19 kilowatts. Then we will use our equation for the efficiency. Then substitute all the values given and the output power. Then this will give us 90.48%. Practice problem number 2. A three-phase 25 kVA 220 volts alternator delivers rated kVA at 0.84 power factor. The effective resistance between armature winding terminals is 0.18 ohms. The field takes 9.3 amperes at 115 volts if the friction and windage loss is 400 watts and the core loss is 610 watts. Compute for its efficiency. So there we have the following given, and we are asked to solve for the efficiency. So for our solution, let us solve for the output power. That is the apparent power multiplied by the power factor, and that will give us 21 kilowatts. For the line current, it's simply the apparent power all over the square root of 3 multiplied by the line voltage. Then substitute the values, and that will give us 65.61 ampere. For the copper losses, simply we will use our formula 3 multiplied by I squared multiplied by the armature resistance, and that will give us 1.16 kilowatts. So the resistance is 0.18 ohms between armature winding terminals. So we have to divide it by 2. Then for the field winding losses, simply substitute the 115 volts multiplied by 9.3 amperes. This will give us 1.07 kilowatts. So the summation of all power losses will give us 3.24 kilowatts. And substitute to our equation, this will give us an efficiency of 86.63%. Let's have practice problem number 3. A 2300 volt, 1 megavolt ampere, 0.8 power factor lagger, 60 hertz, 2-pole, Y-connected synchronous generator has armature resistance of 0.15 ohms. Its friction and windage losses are 24 kilowatts. Its core losses are 18 kilowatts. The field circuit has a DC voltage of 200 volts and a 10 ampere field current. Determine the efficiency of the alternator. First, we have to write all the given. Then we are asked to solve for the efficiency. So again, our solution for output power, that will be apparent power multiplied by the power factor, and that will give us 800 kilowatts. For the line current, the same process. We just substitute all the given values. That will be 1 times 10 raised to the 6th power all over the square root of 3 multiplied by 2300 volts. So this will give us 251.02 amperes. And we will also use or solve for the copper losses. This will give us 28.35 kilowatts. And for the field winding losses, substitute the value of 200 volts and 10 amperes, then this will give us 2 kilowatts. Then we will get the summation of all power losses, and we will get 72.35 kilowatts. Then using our equation for the efficiency, substitute all the given and computed values, then this will give us 91.71% efficiency. So that's all mga ka-wisdom. So again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat!